Hey guys, so in today's video I'm going to be talking about stacks. More specifically, I'm going to be talking about what they are, the implementation methods for them, and at the end of the video I'm going to be using a stack to demonstrate sort of an example of how we can use a stack to really show off how we would use it in an application. So let's go ahead and really explain what a stack is really quickly. A stack is essentially a abstract data type where it is, well, it's a stack. And although this sounds incredibly unhelpful, it is easy to visualize it. So let me explain. Let's say you have a stack of books. You have books A, B, and C. A is at the bottom of the pile, B is in the middle, and C is at the top. If we wanted to return book A, we can't just take out book A from the bottom. We need to remove book C, then book B, and then finally we can return book A. This is same for a stack. A stack follows the FILO, or the FILO idea, which is the first in, last out idea. So, how do we code a stack? Well, let me show you how. We're going to create a new class here. It's called a stack X, and we're going to go ahead and start coding. So, first things first, we need some variables. So our first variable is going to be a private integer called top. The top variable keeps track of what is ready to be popped from our stack. It is the next element to be popped. It acts as a pointer for us. Next, we need a private integer called max size. This isn't required, but I like to keep track of how many items are in my stack. So let's create a variable called a private integer number of items. And then let's create a private character array called stack array. Alright, now we have our variables. So let's go ahead and create our constructor for this class. Our constructor is going to be called stack X, since constructors must always share the same name as its class, and it's going to take the parameter of integer max. Now, for our constructor, we need to do a few things. We just initialize top equals to -1. We set it to equal to -1. That way, when we push an element onto our stack, we increment top by 1, and it's able to keep track of the next element to be popped. We're going to then set max size equal to max. We're then going to say number of items is initialized to 0. And we'll go ahead and say that the stack array is equal to a new character array with a size of max size. And here we have our constructor. Now we can go ahead and code our methods in. So our first method is the push method. So pushing is essentially adding an element to our stack. So it's a void method. So it's a public void push. We can take a character J for us because we're going to be using a string layer to demonstrate a stack and using it in an application. So we're going to take character J. Here we're going to say that the stack array increments by 1 is equal to J. And we increment it before rather than after, because if we were to do it after, it would actually try to assign whatever character J is to -1, and that would give us a index out of bounds error. So to avoid that, we increment it before. Next, we need our pop method. We want to actually return this, so it's a public character method. Call it pop. It takes no additional parameters. And we're going to say that the stack array decreases by 1. I actually need my return statement right here. I forgot about that. Then we need our peek method. So we have a public character method called peek. And the peek method essentially tells us the next element that is at top. So it allows us to see what element's ready to be popped. So we can go ahead and call public character peek, and we just return the stack or what is at the top of our stack array. Then we have a few more methods. We have the public, we have the size method, which is actually going to return an integer. So public integer size is going to take no additional parameters. And then we're going to say that we just return the number of items. And this is actually where I forgot to do something. We have to be incrementing the number of items for whenever we push an element into an array, and we have to be decreasing number of items whenever we pop one from our array. Size, we just return the number of items, as this tells us the number of elements in our stack. Now we need another method. We need the boolean is empty method. So it can be a public boolean is empty, and we're going to return true if top equals -1. And then for our is full method, we're going to say, we're going to go ahead and return true if our number of items is equal to the max size. And excellent. This is our stack. These are all the methods we have for our stack. So if you look at how this works, it's really not too complicated. We have top equals -1, which acts as our pointer throughout our stack. We have the number of items, which sort of keeps track the number of items or elements we have in our stack, so we can easily call that in size and check if it's full. So we can either return top equals -1 here, or we can return number of items equals 0, either one. So we have our stack. Now, how do we use this? Well, for my example, let's go ahead and create an application that reverses a string using a stack. So let's create this, and let's call this the string reverse app. So as I create a new class here, let me just explain why we want to use a stack for this. Well, a stack, as I said, incorporates the Philo rule. So if we were to push individual characters into our stack and then pop them out, our string would be returned in a reverse order. So let's go ahead and code our first class here for the reverser. So let's make a new class here called the class reverser, and we want to take two variables here. We want to take a string called input, and we want a string called output. Excellent. Now, again, we need to create our constructor here. So we call a public reverser. And it's going to take the parameter of a string called integer, a string called in, and we're going to say that input is equal to in. And this is really the only line of code we need for our constructor once my computer stops lagging. There we go. Now we can actually get into our reversing method. So we need to return a string here. So let's call this public string do reverse. Now we have to do a little bit of work here. So what I like to do here is instead of typing out .length every time, I like to just set it to a variable. So let's say max size is equal to the input .length of that string. And then now we need to create our stack. So we can say stack x. So let's create our object. Our stack is equal to the new stack x with the size of max size. This essentially creates a stack that is the size of our string, so we don't have one less or one more than we actually need. We have the perfect amount every time. Then we need to actually iterate through our string. So we can say for integer I equals 0, I is less than max size. We're going to increment I by 1. I keep hitting that one key there. That's so unfortunate. And then now, as we iterate through our array, we can say that for a variable called ch, it is equal to the character input at I. So, let's say we were to take the word dog, three letters, 3 elements, very simple. In the first iteration of the loop, we will be character ch would equal d. The second iteration, ch would equal o. And the third iteration, ch would equal g. Now, we want to push this into our stack, so we say stack.push ch. So we have now pushed our entire word dog into the stack. Now we want to pop it out. So this is why we have the isEmpty method here. So we can say while stack dot is empty. We go ahead and say that while the stack is not empty, character ch is equal to the stack dot pop. So every time we pop an element from our stack, it is now equal to ch. And then we can now go ahead and say that our output is equal to output plus ch. And we can go ahead and just return our output. This assembles our string in a reverse order. And I actually forgot one line of code here. And we actually need to initialize output to blank parentheses, since if we were to just run it without this line, it would return null. So for example, if we were to try the word dog, instead of returning a God, it would return null God. Right, so this is our reverser, and let's go ahead and test it out. So let's go ahead and make our main class, so public static void main string arguments. Now let's go ahead and do this. So let's actually make this a little interactive with the user. So let's go ahead and import a scanner class. So we're going to go ahead and do that by importing it from the Java. And then we're going to go ahead and create a new scanner object. Scanner sc equals a new scanner. That goes ahead and do that. And now let's prompt our user for something. Let's say something like system.out.print please enter a string. Now we can go ahead and say that the string input is equal to the next line. Great. Now that it's set to the next line, we can go ahead and say that we can go ahead and create our reverser now. So our reverser reverse equals a new reverser, and it's going to go ahead and take our input. Now we need to actually reverse it. So we can just actually call it here, system.out.print. And if we want to reverse our actual string, we go reverse.do reverse, and there we have it. So now if we were to run this, it will pop up in the console beneath us, and then it will ask us to please enter a string. We will enter a string, and then if everything goes as predicted, it should return, the reverse of a string. So let's see, please enter a string. Let's test it with something like dog. It returns God or God. Let's try it one more time, and let's try it something a little longer to make sure it's working. So let's say this stack reverse is really cool. So you see, even since we're using a character, it will even take it will take all characters. So this is the conclusion to our my stack video. Our next video will be covering what queues are, and we'll be showing implementation of all the queue methods, as well as how sort of an example program we can use a queue for. If you guys have any questions or comments, please leave them down below. They're much appreciated. And for now, that's all.